In this video, we're going to be talking about proving triangles congruent. And there's good news. The good news is no numbers, or at least no major calculations. All right, let's get on with it. The manner in which we're going to prove triangles congruent are sometimes referred to as shortcuts. So we have our four basic versions: the side-side-side, the side-angle-side, the angle-side-angle, and the angle-angle-side. Now, the order of the words that I spoke are important, as you would guess. So first, let's just take a brief cruise through about what three pairs of congruent sides looks like. We got a pair here, we got a pair here, and we got a pair here. That would be an example of side-side-side congruency. How about side-angle-side? Two pairs of sides, right, and the included. So I would sort of underline that, double underline the word included. So say it was this angle was congruent to this angle, but that's it. Those are the only angles that are congruent. And then we had a pair of sides here. If we want to make that the included angle, it has to be between the two congruent sides. So notice that this angle is sandwiched between the two congruent sides. So you would have side, angle, side, side, angle, side. And of course, there are corresponding sides and angles. Next, we move on to angle side angle. Angle side angle is just like side angle side, only angle and angle are flanked on the ends, and side is sandwiched in between. So say we had this side and this side marked congruent. If that's to be the included side, then I would need this angle to match up with this angle, and these two angles to match up as well. So that we now have angle, side, angle. Again, the common side has to be sandwiched between the two corresponding angles. Now our last player here is angle, angle, side. So we're going to have two angles on both triangles that are congruent, and then one pair of sides opposite them congruent. And by that we mean this angle perhaps is congruent to this angle, and then this pair of angles are congruent to each other. So we have an angle followed by an angle followed by a side. So perhaps that would be the side there. And another option will be explained further when we blow these up a little bit more. But that's the gist of the shortcuts. Let's move on. As you roll to the bottom, we have the hypotenuse leg. Now, obviously, if we're talking about a hypotenuse, we're talking about a right triangle. So we already have a pair of angles congruent if you have two right triangles. So what we need in addition to those angles is the hypotenuse. If we know that the hypotenuse of each triangle are congruent to each other, and one of the legs. So I'll just grab the two bottom legs on. It doesn't matter which pair, but as long as you have the hypotenuse of each right triangle being congruent to each other and a pair of corresponding legs, well, you know you have the angle. So because of the Pythagorean theorem guarantees us that this side squared minus this side squared gives us this squared side, well, then that would give us the same length over here. If we use the same values on both sides, if we perform the Pythagorean theorem, I know I'm going to get the same exact answer here. So this is kind of like a little fake version of the side-side-side. Okay, now how about down at the bottom? Well, there are some things that we need to recognize, like reason sides might be congruent is because we told you they are, right? We give you a picture that looks like things are marked congruent. Or maybe we told you something was a midpoint between two pieces. So if I said, hey, this is the midpoint, well then obviously this piece and this piece are congruent to each other. And then perhaps the reflexive property. So maybe we have two triangles back to back. Well, this side right here is the same length side for the triangle on the left and the triangle on the right. So of course it's congruent to itself. All right, that's what reflexive means. Then of course down at the bottom, why are angles congruent? Well, again, because it's given, or because they're vertical angles, alternate interior, alternate exterior, corresponding. Perhaps we split an angle in half, right? We have the angle bisector, so we would have created two congruent angles. So all of these are reasons for angles being congruent to each other. So it's not always that we're going to straight up show it to you that it's congruent, sometimes you're going to have to infer. You're going to have to think. That's the whole point. From time to time, you may have seen people coming into class asking, why are you doing this? And it's the same reason I've said over and over this year, that mathematics helps to build my logical reasoning skills. It also helps to strengthen my decision-making skills. That's one of the number one reasons you do all of mathematics. It's not for the mathematics itself, although that's another great reason, but math really strengthens your logical thinking skills and your decision-making skills. Like it or not, that's why we do this. Down at the bottom, once we've established that these triangles are congruent, then don't forget the whole concept of CPCTC. Corresponding parts of congruent triangles are congruent themselves. So if you have triangle ABC is congruent to triangle DEF, then AB is congruent to DE, and BC is congruent to EF, and AC is congruent to DF. And then we can go around the horn on the angles and say that angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. And we should be able to write all that in as well. Press pause and copy it in. Okay, hopefully you have all this in your notes. Let's move on. So let's get started. We're going to dive into side, 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 and side angle side a bit further. Now we know that if all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, we can prove triangles are congruent using fewer parts. Like how about just 3 pairs of sides? When I look at the triangles right here, I notice that AB is the same as DF, or rather DE. And so I'm going to write that over on the right side. As I move around the triangles, I see that BC is congruent to segment EF, so I write that in. If things are moving a little too quick, press pause if you need to. On our last side, AC is congruent to DF, and I want to keep in mind that the order in which I write things matters, so I want to make sure that my corresponding angles are staying lined up. So what do I have? I have 3 pairs of sides, or side, side, side. Congruence postulate says that triangle ABC is congruent to triangle DEF. And how do I know that? Because I have 3 pairs of congruent sides. And if I have that, then automatically I know all of the angles are also congruent. So now I know that every last piece of these triangles matches up quite nicely. And all I needed to say that was the 3 sides. Now I know everything. Well, I know everything matches up. I don't actually know everything. So this next shortcut then, Sideangleside, says that if we have 2 sides and the included, circle included, if I have the 2 sides and included angle of one triangle congruent to 2 sides and the included angle of another triangle, then everything about them is congruent. So is that what we have here? Well, let's take a look. I know that I have this side and this side are congruent, and this side and this side are congruent. The question is, are the angles that are sandwiched between those two congruent? I mean angle B and angle E. So if that's the case, then I definitely have side, angle, side. So let's take a look. At first view, I do have segment AB congruent to DE. So I wrote that here. And then on the other side, I have segment BC congruent to segment EF. So I have that. And coincidentally, I am given the fact that angle B is congruent to angle E. So angle B is congruent to angle E. And that is the included side between the two congruents, or the included angle, I should say, between the 2 sides. So I do have side, angle, side. So at the end of the day, triangle ABC is congruent to triangle DEF. That is, that the sides that aren't marked congruent are now assumed to be congruent because I know that the triangles overall are congruent, and since that's the case, CPCTC states that everything about them is congruent. All right, let's keep going. Now if you flip ahead a page or so, until you see the homework 5, and about in the middle of the page you'll see something that looks just like this. And we're just going to take it easy and try a couple of these. So just focusing on side, 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 and side angle side. Do we have enough to use those shortcuts? Well, I'm looking at number 1 here, and I see that I have a side here with a single tick mark and a single tick mark over here. So that gives me 1 pair of sides. Okay. Segment QY is congruent to segment CK. I also have a second segment over here and here. So let's write down that congruency statement. We have a second pair of sides. So segment YT is congruent to segment KP. Now, that I see these congruent sides, the question is, are the angles between them, the included angles, congruent? And what I'm talking about is angle Y and angle K. And it's easy to see who it is because Y is mentioned twice, K is mentioned twice. That's how I identify the angles that need to be congruent. So is angle Y marked or known to be congruent to angle K? And yes, I see the arcs, single arcs in each one, so I do have side, angle, side. So it says state whether the triangles could be proven congruent, and if so, write a congruency statement. So let's go ahead and wrap that up. Now the order matters, so I'm going to start with Q, and what I said is, hey listen, these are congruent by side, angle, side, and I start at Q and I make my way towards Y. And I finally go from Y and make my way to T, calling this angle, or triangle, QYT. And who's that going to be congruent to? Well, I went along the single tick mark towards that marked angle. So along the single tick mark towards this single arced angle is triangle CK, and then down the double, just like I went down the double here, to P. And that's our final answer, side angle side, and our congruency statement. Let's try that again for triangle number 2. Now what do we see here? I see that these two sides are marked congruent, and if you draw the triangles sort of separated like this, this is what I see so far, that I have 2 pairs of sides. But this side AC is the same side on both. So this is that reflexive property that we were talking about earlier, that this side will certainly be congruent to itself, and hopefully it's obvious that we have all 3 sides. So all we really need to do is name the first triangle in any order that we'd like. So I call that triangle ADC. Now if I went from A out towards D, I went along the single tick side towards the double tick mark side. So it's going along that same route over here. I'm going to go from bottom up. So that's going to be from C to B and then back to A. Whereas over here we went from A to D and towards C. So triangle ADC is congruent to triangle CBA. And the point that we're trying to make here is that we do have some corresponding angles that are congruent. Who are they? Well, I know that angle A is the same as angle C over here, and D matches up with B. How do I know? That's where the double and the single meet. That's where the double and the single meet at D. So C on this left side is congruent to that angle up there. All right, let's move on. For number 3, I think it's easier if we had maybe some colored pencils. Feel free to borrow some from me if you'd like. But what I've done is I've traced over the 2 triangles that I'm looking at in red and blue. And I'm going to pull those apart down here so that we can see them better. Now if you'll notice, I've labeled this triangle accordingly, JMK, and this triangle accordingly, LMK. And I've provided the notation that I was given. This is the given information. So it was given that JM, segment JM, is congruent to segment LK, and it was given that angle K is congruent to angle M. But do we have anything else? Well, it should be noted that I see some vertical angles over here, but that doesn't really do us any good with respect to these triangles. Do I know that K and M are congruent? No. Do I know that J or L are congruent, the angles? Nope. But I do know that this side down here is the same side on both triangles. So again, that reflexive property says that MK is going to be congruent to MK. And now what? Oh, I have myself a pair of sides and a pair of sides congruent, and the angle included is also congruent. So it looks like we have side, angle, side congruency. So I'm going to go ahead and say that these are congruent by side, angle, side. And then for our triangle congruency statement, we're just going to state the left one in any order. J, triangle J, M, K is congruent to. Now if I start with J, then I'm going to start with L on the right side. And if I went from J to M, I guess I'm going to go from L to K. And then finish up at M. And that's about how that's done. Moving on. Our next example looks pretty interesting. Looks like we have a pair of sides here and a pair of sides here. So we got side and side. Now the question is, I do have a pair of angles right here that are marked congruent, but is that the included angle? Where these two congruent sides meet are sandwiched together over at T, and these two sides sandwiched together over at S. Are S and T the angles that I've been given congruent? And the answer to that is no. So this is not the included pair of angles. So even though I have a pair of sides and a pair of angles, it's not the included angle, so I don't have side, angle, side. These aren't shared sides, so I can't say a third side by reflexive property, so these are not congruent, and that's that. So for 5 through 8, you complete them. Right? You complete these and check them in with me, but I've given you some ideas to think about. For 5, think about the concept of a reflexive side, a shared side. On 6 and 8, think about some vertical angles that aren't marked congruent, but that you could mark congruent because they're vertical angles. And over here, the question of, is it the included angle? I see that they're marked congruent, but are they included? All right, so I think you're going to have a little bit of everything going on in here. One last piece of advice. On number 6, I see this extra set of arrows that reminds us that we are dealing with a parallel situation. Got myself a nice little transversal. So I have alternate interior angles here and here, and alternate interior angles here and here. So think about that. Here's your transversal and your parallel lines. So perhaps this angle and this angle right here are congruent due to alternate interior. Think about that. Feel free to stop what you're doing and pop up and ask me a few questions if you need to. When you're done with those few examples at the bottom, pop back up to the top of the page. You got a few more side, 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 and side, angle, side examples. A couple of them are super home runs. Number 2, think about vertical angles again and that concept of parallel lines. Number 4, think about that reflexivity. And number 6 as well. Over on number 5, maybe a vertical angle here. 3's got that reflexive property, so try something. Check in with me if you have questions. Don't forget to start marking these things up. If you discover that something's congruent, then place that congruency symbol on your diagram, like right here. Add in that these angles are congruent because they are vertical. And don't forget that there's some alternate interior stuff here. You could always throw in a double tick mark right on number 3 for that reflexive side, so on and so forth. When you're done, keep moving on. Like always, at first this is a lot of information, but remember, we're going to take a couple days to get this thing squared away. Now as we move into the hypotenuse leg, remember that we already have 2 sides of that right triangle, and we know that the Pythagorean theorem, that a squared plus b squared equals c squared. So all we're saying is, look, if you have the hypotenuse the same on both of them, and then you have a pair of legs the same on both of them, then b is going to work out to be mathematically the same answer. So really, hypotenuse leg is like side, side, side for right triangles only. So we're in good shape here. So take a moment, make sure that you catch up with my notation over here. If BC is congruent to EF, then we have the hypotenuse. And segment AB is congruent to segment DE, and we have a leg. Then ABC, triangle ABC, is congruent to triangle DEF. All right. 2 more, couple of examples, and you're home free. Here we have angle, side, angle. And just like it sounds, a pair of angles congruent with the included side, the sandwich side. So what do we see over here? I see that I have angle A is congruent to angle D. Right? We got angle D and angle A. We also are given that angle B is congruent to angle E up at the tops here. And then I have this segment here is congruent to this segment here. And that is the side that connects the two angles. Just like before, it was the angle that connected the two sides. So that is the included side. So we have segment AB is congruent to segment DE. So we are in great shape to use angle, side, angle. And we just want to make that congruency statement, that triangle ABC. Right? The order in which I say it matters is congruent to triangle DEF. It's a good time to just practice an alternative statement. How about if I said triangle CBA? Well, then that would prompt me to say on the other triangle, triangle FED, right? Because order matters, and when we're talking about that CPCTC, things have to match up, right? The order in which I say things matters because angle C matches up with angle F, angle A matches up with angle D, and that's what I was given at the beginning, so it's important that all of that order connects. This brings us into our last congruence shortcut. Angle followed by another angle followed by a side. Angle, angle, side. So I have angle A congruent to angle D. Okay, so angle A is congruent to angle D. That gives us an angle. Next, I slide along to angle B and I slide along to angle A. No side between them is congruent, but the angles are one right after another consecutively congruent. So angle B is congruent to angle E. So that gives us another angle. And then right after that, I keep moving around or clockwise around that triangle, and I have segment BC is congruent to who? Counterclockwise, keep going this way, I got segment EF. So the order in which these things shows up matters. The side is not the included side, it's the side that is just after, the non-included side. Right? So I have two angles and a non-included side, congruent to two angles and a non-included side, so I have angle, angle S, or angle, angle, side. And so I'm just going to write the congruency statement down here. I'm going to say triangle and just shake it up a little bit. Triangle BCA is congruent to who? Well, I got to match up those angles. So if I start with angle B, I got to start with angle E. So E. And if I went from B to C, then I'm going to go from E to F and then back to D. Now originally I knew that triangle A matched up with D. Does that work in my statement? A is last, D is last. Looks good. B goes with E, they're first. That's good. Looks like I got the order in good shape. So here we are, a few more examples. You'll be on your own, and then we're all squared away here. All right, this first triangle, all they want me to do is identify which of these shortcuts works, if any, and I'm going to write that in the box, but we need to make some identification here. So what do I see? I see that I have a pair of angles, and down here I got another pair of angles. So I definitely have angle and angle. Now I have the side between them is shared, so by reflexive property, that's congruent to itself on both triangles. So I guess I have angle, side, angle for this one. And let me just tease these triangles apart for you. So if you notice, I kind of have this maroon one and the pink one, and this is all kind of moving on me. But the bottom line is, if you kind of push the maroon one off to the side, all I'm trying to highlight is that this side here is this side here, and that's how I know they're congruent. We were given that these angles matched up, and we were given that these angles matched up. So I have that angle, side, angle. Okay, let's keep going. Number 2 is what I refer to as a super home run. We got a pair of sides on each triangle, and we got another pair of sides on each triangle, and we got this common side, so that's congruent to itself. So I guess this one's going to be side, side, side congruence postulate. And I kind of go in out of order just for fun. We have this shared side on number 4, so I know that that's a reflexive piece, so that's going to be congruent to itself. And I have another pair of sides over here, and these are right triangles. So if I think about this, here's a right triangle down at the bottom, And then here's my right triangle up at the top. So I have the hypotenuse is the shared piece. So I have a hypotenuse, and I have a pair of legs congruent. So I think by hypotenuse leg theorem that is going to work out. Let's head back into number 3. So on number 3, what we have is a pair of congruent angles up here, and then we have a pair of congruent angles right here. And I've been given that we have a set of congruent sides. But how is this working? I go from a single arc to a double arc to the side, from a single arc to the double arc to the side. So that sounds like I went from angle, angle to the side. And angle, angle, side is one of our options. Be careful, angle, side, side is not one of our options. Okay, that spells a bad word, so we're not going to use that one. Let's move on. All right, our last 4 examples, and then you'll be on your own. On number 5, first we want to take a moment to recognize that we do have a pair of vertical angles right here. So we have a pair of angles. And then I have a pair of side right here. So I got a pair of sides. And I got another pair of sides right here. So that's another pair of sides. So do I have side angle side? Because that's the only thing that'll work. Again, there is no SSA. And so I'm thinking about this, and well, are, I should say, these angles included between the 2 congruent sides? And the answer to that is a resounding no. This is where the included angles would have to be. And they're not marked congruent, there's no parallel sides, so I think all we have here is just not congruent. All right. Moving on to number 6, I do see that I have a pair of parallel lines here, and that would make this, that would make this transversal here up here. And if that's the case, then I think I have corresponding angles right there. Now because of that, I notice that I have the corresponding angle, a congruent side, and an angle. And then corresponding angle here, congruent side, and another angle marked congruent. So it looks to me like we have a pair of angles, sides, and another pair of angles. And that side is sandwiched between those 2 angles, so angle, side, angle does the trick. Number 7. On number 7, we have the shared side, so that's going to be congruent to itself. And as I go through the looking glass here, I got a pair of congruent sides on the outside. I got a pair of congruent sides here on the inside. And sandwiched in between those 2 sides, I have the included angle. So right here, this is a pair of angles on each side, the left side and the right side. They're marked congruent, so I have side, angle, side, and side, angle, side. So we are in good shape for side, angle, side here. And number 8, total home run, shared side. That's going to give us the third of 3 shared sides, 1, 2, and 3. So that's going to be side, side, side. So go ahead and wrap that up. All right, you're going to complete the rest of this page on through 12, and then when you're done, check in with me. All right, don't worry if you get a little bit overwhelmed. It's to be expected. We will work through this, and when we're done taking the proper amount of time to give you some time to mull this all over, you'll be in great shape and on your way to a couple of days off. All right, check it in when you're done, and we'll go from there. Take care.